Good afternoon and welcome to Paragon Films' presentation on General Equipment Training Part 2. My name is Adam Lucken and I'm the state rep of Kentucky for Paragon Films. A little bit about what we have done so far. We began our webinars talking about the different films that Paragon provides and the different film characteristics that each of our films have. In part 1 of our equipment training, we covered different types of equipment out in the field and the basics of issues that may happen with these pieces of equipment and how we might be able to solve those issues. So now in part 2 of this, in the general equipment training, we are going to bring both of these together in terms of the film and the equipment and talk about containment, which is obviously the objective and the purpose of the equipment. And what we use the film for is providing, obviously, containment for our pallets, for our customers' pallets. So together, we're going to bring that all in and go over the different types of stretch wrappers. Again, we covered this a little bit in part 1, but more so today, we're going to focus on how they differ in terms of containment. And then we're also going to discuss the different factors that affect containment. So this can be found in the equipment settings with wrapping patterns, how rotational and carriage settings can affect containment. And this is all going to be found on control panels. So we are going to look at control panels as well and the different varieties of control panels that are out there and what our control panels allow us to do. And then we're also going to talk about how we collect and analyze this data in terms of containment, how we measure containment out in the field, and how we input this into our client analysis. So with containment, there are over 15 billion variables that affect containment. If you were to factor all of this in, it'd be 15 billion. So that's different pre-stretch ratios, resin manufacturers, equipment manufacturers, different machine films, the layers in the film, all of this provide different variables for containment, but containment is the only thing that we really can measure and the only thing that we can really control. And so it's important that we set a containment standard for our customers so that way we understand and are sure that the film and the machine are working together to provide that optimal containment. In situations where there isn't a containment standard for our customers, even furthermore, it provides us an opportunity to get in there with our customers, help educate, help learn from them and with them on how we can provide the best relationship for their film and for their machine. Common factors that affect containment that we've narrowed down here are the film gauge. Film gauge is probably the most commonly asked, but it's not the only variable, but it is probably, like I said, the most commonly asked. It's important to note that 70 gauge is not always the same 70 gauge, especially when we're talking about different manufacturers. For Paragon alone, we have 5 different 70 gauge films, and that is no accident. Each of those 70 gauge films provide have a different film characteristic that allow it to perform a certain way depending on the application needing, and that all affects how its ability in terms of containment. Pre-stretch gear ratios that we talked about in part 1 inside the film carriage, these also have an effect on containment levels. You have the rotational and carriage speeds that affect containment for the pallets, as well as which also impact overlap and overwrap. You also have tension that has a great impact on containment. All of those there are things that the customer has control over, right? They can pick the film gauge, they can set the pre-stretch gear ratio or change it need be mechanically or with a trained technician. But the rotational speed, carriage speed, the amount of overlap or overwrap, the tension, all of those are settings within those panels that we're going to discuss a little bit further. There you see at the bottom is stiffness versus softness of film. This is something on the manufacturer's end, something that we differ and something that we that really changes their performance the film's performance in terms of containment. So we'll talk about that a little bit later as well. So here you see a variety of different wrappers that we discussed at length in part 1. You have the turntable, the rotary arm, the ring. The point that I really want to bring here is that different types of equipment provide different types of containment, right? So you have a turntable that ranges from 8 to 12 RPMs, whereas a rotary arm or a ringer, they can range up to 60 plus RPM. And because of that, because of those rotational speeds and because of the equipment, you get a different type of containment. So it's important to understand that when we're out in the field and when we're working on this equipment, how the equipment itself might impact the or might impact the containment levels and the containment performance of the film and the overall on pallet stretch. Now looking at the control panels, obviously there are a variety of different control panels, and especially if you haven't seen one of a specific type before, it can be pretty overwhelming. I know for myself that's true. But nonetheless, it's important to note that though they all look different, they all have and serve the same basic idea, the same basic services in terms of tension or force to load, rotational speed or carriage speed, top to bottom wrap counts, as you see on that Landtech there and the Q series on the left, right, the top and bottom. You can affect that. You can change that turntable speed or roll carriage speed or that wrapping force, that force to load. All of this helps us achieve the optimized containment that we are trying to find for our customers, for their pallet, for that application. Now, as some of these are pretty standard level wrappers, also some of these are more high tech. So it's important to note that too. Depending on what kind of equipment you're working on, you might get a more personalized, more exact sort of containment for your customer. For instance, you may have a more high-tech wrapper that allows there to be different settings for different recipes. So rather there being in one standard setting that all pallets are wrapped under, now you have a variety of different settings that it's automatically programmed for. So that way your customers' pallets are wrapped, though they may be different, are wrapped at their optimal levels of containment. So like I said, every piece of equipment here is unique and different, but they all serve and do similar things. It's important to note what exactly changes what and how that impacts containment. So with the photo eye or the lower limit switch, that's what really affects your top wraps and your bottom wraps, right? And it's important to know, especially with the photo eye, we talked about that in part 1, making sure that that is calibrated right. So that way the pallet or the photo eye understands exactly where the pallet ends and therefore gets those correct numbers. You also have your carriage speed and rotational speed that affects the overlap, which is how much film covers the previous layer of film, right? That's the basic overlap. If you were to change that carriage speed way up and that rotational speed way up, you end up getting very little overlap, excuse me. Whereas if you were to vice versa, turn that all the way down, both carriage speed and rotational speed, now you're getting a lot of overlap. And both of those differences have an impact on containment, right? So it's important to understand the relationship between those two speeds and finding the optimized amount of each for your customer's loads. And then of course you have overwrap, and that's the amount of film that is wrapped over the top of the pallet. And it's important to note there too, in terms of overwrap, how much overwrap is really need for your customer's pallet, right? Some customers may have an application that puts a top sheet over the pallet at the end. Therefore, they don't need much of an overwrap. Other customers may not have this and they will need more of an overwrap, but it's really to just ensure that we understand the right amount of overwrap depending on the application and how that really impacts the overall on-pallet stretch, that levels of containment and where it's really needed and when it's not. Of course, with digital control panels, like we said, now you're getting more of a customized control. Kind of what I said earlier, you can set up different types of recipes that can provide a more customizable solution depending on what application is necessary or needed. And then this new technology also allows us in-cycle adjustment, so we can go in and manually change, different tension settings as well, and ensure that on the job, on spot, we can correct these pieces of equipment and provide the right amount of containment. So as we talked about, rotational speed has a great impact on containment. You can see on the picture there, you have the revolution counter and the turntable rollers, in which the turntable will revolve around to get that amount of revolutions for the containment. Turntables typically 8 to 12 RPMs, like I said, overhead ringers 60 RPMs, and all of this impacts containment, right? So depending on the speed of the rotation of the turntable, you're going to get a certain level of force on the pallet. So lower rotation on the turntable or on the ringer, you're going to get less force onto the pallet, less force of the film on the pallet. Whereas if it were higher RPMs, you're going to get a higher load force or force onto the load. So it's important, again, understanding the equipment capabilities and understanding the effect of rotational speeds and how that affects the levels of containment we can achieve, or in understanding the balance between that rotational speed and carriage speeds, right? So carriage speeds have a great effect on the overlap of the film, which greatly affects the on-pallet stretch, right? And the overall containment. So too fast of a carriage speed, especially with too high of a rotational speed, you're going to get no overlap of the film with no real overlap of the film with the pallet, which is going to really provide limited containment levels. Whereas if you were to dial in and really optimize both of those levels, the carriage speed and the rotational speed, you can get the right amount of overlap as well as the right amount of force to that load. And it's important to note that speed isn't necessarily the best answer here, right? And it's really about finding that balance of rotational speed and carriage speed, providing that together to ensure that the pallet is secure or the product on the pallet is secure and well organized. In terms of roller patterns, we discussed this in part 1, so I'm not going to go in great detail about this, but the thing I really want to focus here in terms of containment is the difference in terms of how much contact the film has with those pre-stretched gears on the S style relative to the W style, and how this really affects that F1 force, right, of the film as it goes onto the load, where those F2 forces that we discussed with the rotational speed, tension, carriage speed, those F2 forces, how that really affects the on-pallet stretch. So it's really important to recognize the differences between the W style and the S style, in terms of how that affects the pre-stretch of the film. So it's a commonly noted thing in the field where we believe that compression and stiffness is what equals containment, right? So compression is more of what the customers can control in terms of that carriage speeds, the gauges, gauge of film that they want to use, that pre-stretch setting, that force setting, whereas the stiffness is more so the manufacturer's control, right? And so it's important to note, especially for the customer's control, how these can be changed and adjusted to achieve that overall goal of getting a product shipped from point A to point B with optimal containment at the lowest cost per pallet using the least amount of film possible, which is a big part of Paragon Films' belief of savings for the customer and savings in terms of sustainability. So with customer controls, right, we can change those carriage speeds, we can change the rotational speeds, we can pick which gauge of film we want to use depending on what the application is, or what type of which gauge we want to use for which film. You have the pre-stretch that can be mechanically changed. We can change out those gears. We can change out those rollers. And then the force settings, of course, the F2 settings that we talked about, those are other things that we can change on the customer side to affect the containment levels of the film. On the manufacturer side, right, that stiffness is where we come into play. So manufacturers, we have our Nexus UVI, Nexus Contrast. These are all stiff films, right? And there's an actual purpose for that. We believe that the high resistance to stretch allows the product to work a lot better for your equipment. So by having a higher resistance to stretch, when it does stretch, you're getting higher performance in terms of containment. Those performance characteristics are really important. And then depending on what usage it might be, so Nexus UVI being with that UV additive that allows, or UVI additive that allows it to perform well in the outdoors. You have the contrast, that's a one-side slip. These are all engineered for containment for the right application, dependent on what your customer is looking for. And again, that is our overall goal, getting our product from point A to point B with the optimal containment at the lowest cost possible. So how do we exactly measure exactly what the containment levels are? Well, if you've been out in the field with us, I'm sure you've seen us with our handy dandy toolbox, and we have a variety of tools that we use to really measure exactly what the performance of the machine in the film is. So with that, we're able to measure the containment forces, the top, middle, and bottom of the load. We're able to count the amount of revolutions, and that goes into our calculations for pre-stretch and on-pallet stretch, the feet of stretch film and unstretched film, all of which help us measure exactly what kind of containment we are getting and where we might need to improve and how we can improve. And we obviously, when we are outperforming a test, we use the current settings that are on the equipment, and we run it with the current film they're using and the film we recommend. And then we take an opportunity to optimize that machine, that equipment, to the film, to our film's capabilities, to really find where we can improve. So when we're out there in the field, we're using that torsion tool that you've seen on the top left there. And that torsion tool, it's important to understand with all of these tools here, except the load cell on the bottom right, that there is human error to be had, right? If I were to take that tool and to measure it, I'll get one reading, and chances are if someone were to do the same thing at the same point, they might get a different reading. So they're not perfect, but the way that we provide a standard for that collection by measuring top, middle, bottom, 10 inches by 18 inches with by pulling it, we're able to get a sort of standard of collection of that information, right? We measure, we're monitoring, we're managing all of this information to really find out how can we improve that containment. So of course you have the T-bar in the top right, and you have the pull plate on the bottom left. All of these have human error to it, but we also have that load cell at the bottom right. And what's unique about the load cell is it wraps in with the pallet, and as it is being wrapped, it gives us real-time measurements in terms of the containment forces that it can withstand. And this is something that, if needed for a certain application or in terms of testing, this is something that Paragon can provide and really help out. And it's a great resource that we can support you with out in the field, and obviously for the right application. So in terms of data collection, like I said, we make sure we measure the top, middle, and bottom with that torsion tool, and we make sure we do this on the long side. And this is to ensure that we are getting the lowest settings, lowest containment levels possible, because on the shorter sides, you can get a false high because there's less film on that side in terms of containment levels. So we want the lowest containment levels possible. So we go to the long sides and we do top, middle, and bottom on both sides. And we average out these numbers, and that's how we get our measurements in terms of containment. Now, in some situations, we may need to do more. So we will even go to the short sides and measure those as well, just to get a better accuracy or consistency, depending on what the pallet may look like. You know, difficult steel loads will probably need all 4 sides measured. That's a total of 12 measurements. And we're happy to do that because we understand the importance of consistency in that and by standardizing a method in terms of these measurements to really get the best, most accurate and consistent results. So then we take those measurements and we put them into our client analysis tool, which now is a web-based site for ease of use for our customers and for us reps out in the field. And it provides us a standardized reporting that's put very, very beautifully and easily shown by these graphs here on the side. There may be other companies that provide something similar to what's on the left, and there's nothing wrong with that. It's just can be very difficult to read and kind of hard to understand. So by providing these graphs, it gives us a real visual and ease of understanding exactly where the opportunities for growth may be. We also wanted to provide a separate page for sustainability savings that really show us in terms of sustainability how we are improving with the new film that we are offering. And then of course the overall savings in terms of financial savings, and then the containments and so on. So all of this goes into a very nice, clean, easy to use web-based site that we allow our customers to use so they can best show exactly the performance in terms of containment and savings for their customer. At the end of the day, it's important to remember that equipment performance is key. Film can only do so much, so it's important to know the basic components of the equipment, especially in terms of not just how it should be kept, but in terms of equipment or in terms of containment and how we can optimize this machinery, this equipment to perform at its highest level. So not only being able to see how it's working, understanding what the issues are, but also providing solutions in terms of how can we improve, those containment levels that on-pallet stretch. Because optimizing the equipment to run that film at peak performance in any given situation is always our goal. So with that, if you have any questions, feel free to ask that in the question bar below, or reach out to your local state rep. We'd be happy to answer those for you. You have Alan Abbott in Alabama and Mississippi. You have Zach Poole in the state of Georgia. You have myself, Adam Lucken, in Kentucky, as well as Sean Mitchell in Ohio and Carla Thorne in the rest of the Southeast, which is the Virginias, the Carolinas, Tennessee, Arkansas, and Florida. Again, I want to say thank you for coming out this afternoon. And other than that, stay safe. Thank you.